I'm so pleased to be here. I'm Ed Seidel, now the director of NCSA, the National Center for Supercomputing Applications at the University of Illinois. And I'm so pleased to have a meeting that's actually hosted here in Boulder. It's always great to get back to see the mountains. And in fact, I hope to go do a little hiking actually over the weekend. So it's nice to be out here for that as well. But I wanted to say how excited we are to pull together this National Data Service Consortium. And it sort of sprung up very, very rapidly, in part, in fact, at the last RDA meeting when, in Dublin, when a number of us who were working in the RDA as well began to talk about could we actually organize specific data services at the national level to try to create a national structure for data services. And in fact, we were also thinking about the NSF DIBS solicitation, and in fact a small proposal went in, but as part of that sort of thinking, we built up a lot more steam than that particular activity would really be able to handle. So we decided to see if we could create a consortium of like-minded people who really wanted to build out structures that coordinated not just communities, but really at the infrastructure level, what could be done. And in talking to people, it felt like there were a lot of tools that are basically in place now, but not particularly assembled in a coherent way at a national level. And so we thought this consortium meeting, the first of, and hopefully not the last, of the National Data Service Consortium, would help us define where we might try to go with that sort of mindset going forward. So I'll get into this a little bit more in my talk, but I just wanted to start off with a kind of, that's the idea of what's the purpose of this meeting from my point of view, is to get people together and to figure out what pieces we have, what pieces we don't have, how they might be brought together, and how we might work together. And in fact, I was talking to Achim Streit here, who's come in from Karlsruhe, who leads the Helmholtz Foundation's activity, and reminds me of a few years ago, 15 years ago, something like that, when we were working in Europe. There was a meeting organized around grid computing at the time, and out of that came the European grid, or the e-grid. And in fact, we had no funding, but what we had was a lot of enthusiasm among like-minded partners, particularly people who like to really build infrastructure. And so we managed to do that, and without any funding. In fact, the funding came, though, once the momentum was built and we really had established that we really were a force to do some good for the science communities that we were trying to serve. So anyway, I'll get more into that as we go forward, but right now I just wanted to thank people, particularly UCAR, NCAR, and the University of Colorado. And I'll ask Don Middleton to come up here in a minute, but I also wanted to thank specific people who helped organize this, notably Ray Plant, who's sitting here. Ray, you should just stand up or, be recognized, and you'll be up here in just a minute as well. But so Ray is an astronomer who's been working at NCSA for years and has been extremely important in organizing this particular consortium and the event itself. Lisa Packard for event services. Reed Summers. Reed, you are here somewhere. I don't see you right now, but Debbie Griffin for catering, and Jennifer Williamson for logistical support. So let me turn it over to Don Middleton. Don?
Nice intro, Ed. I'm Don Middleton. I work here at NCAR in the Computational and Information Systems Laboratory, and I am the official host for this meeting that again came together pretty quickly. On behalf of NCAR and UCAR, we're delighted to have the opportunity to host this event. Lots of good folks here. Ed complimented a lot of people. It did come together on a very tight timeline, and also extend thanks to Barbara Jewett and Candace Turner-Jones, who many of you met out there, and again Jennifer Williamson on our side on NCAR. They worked pretty hard to put this whole thing together and get it organized on short notice. I will note that Jennifer is juggling 2 workshops today, so she's kind of busy, but we'll work things out. Wireless. You've got the basic information up here. We have another document we're going to hand around. I don't think everybody got one when they registered because we didn't have them out there. There's another document, like I said, that we'll try to distribute Does everybody have one of these? It's entitled Wireless Access at UCAR. It has more details in case you run into problems beyond that information there. Who has one of these? No one. We're going to hand them out, okay? Restrooms. I'm doing things in order of importance. Wireless, restrooms. Restrooms are right out that door across the hall, okay? So easy to get to. This is our Center Green campus. This is one of 3 campuses we have at NCAR. Across the parkway, we have our Foothills Lab campus with several buildings there. And then down in South Boulder, at the west end of Table Mesa Drive, is the Mesa Lab. And I mentioned that that's quite an architectural monument, if you will. And some of you, if you're staying over and you have some time, you might want to visit that. That was architected by I.M. Pei as one of his first big commissions in his early career. So it's quite something to see. As we go along here, as I mentioned, Jennifer's juggling 2 workshops today. If any of you have any problems or questions, or some of you are staying over and you want some information on restaurants or whatever, you can send an email to me. I'm just Don, D-O-N, @ucar.edu, so that's easy enough to remember. And I'll fan it out to Jennifer or whomever might be the best person to handle that. You've got some nice Boulder spring weather here today. However, tomorrow the forecast is for the low 90s. So once again, if some of you are moving around town or you have a later flight or you're staying over and you're going hiking on some of the nice trails and that sort of thing, dress accordingly. The other thing is that you are a mile high and the air is kind of dry, so take lots of water. And in fact, while you are here, drink lots of water. A lot of people get headaches and stuff. They think it's just from the altitude, but it's often dehydration. And I think that's everything. Does anybody have any questions? Okay. Good morning. Looking forward to a good meeting. And we'll work on getting the wireless information disseminated. Yeah, good. Good, showing a good example there.
Okay, good. Okay, so, and we're going to have Thomas Hauser. Thomas? From UC Boulder, head of research computing. Thanks.
Thank you, Ed. Yeah, I'd like to welcome all of you to Boulder. I was initially involved in the planning, but I think the location here is more closer to hotels and everything. Really exciting that NCSA and the group that pulled this meeting together, bringing all the libraries, the National Computing Center Exceed, the publishers. I think that's an exciting, seeing all these different areas coming together. We have started in Boulder to do some data. We started in 2012 publishing a task force report. We have a small centralized research data group, and we have the two members, so it's small, Shelley from Research Computing and Andrew from the CU Boulder Libraries. But there are also other efforts on the campus that have doing data for a long time. NSIDC, I think there's Lynn here, and then Doug from LASP. So I think we are very interested in trying to see what evolves on a national level on the data. So again, I try to keep it short. I'm German, so I'm getting nervous when we get a little bit over the schedule. So yeah, welcome. I think the weather today was really unusual. It's more San Francisco-like. Normally we really have more than 300 days of sunshine. So I think tomorrow we'll have sunshine. Try to explore Boulder, maybe even tonight. I think the reception is at Millennium. Take a walk along the creek. It's really beautiful there. Or try to take some time, if you stay longer, to go to the national park here. So yeah, all welcome, and I'm really excited about that NCSA and all the others about this meeting, and I'm really interested in the outcome. And I think it's a long road ahead of us. It's not only the infrastructure. I think that's actually the easy part. It's culture change. And I think that's something we need to think about, that we need to change the culture for our researchers and the reward systems. I'm really excited having these publishers here. So again, looking forward to the outcome of this meeting and hopefully a few more meetings. Thank you.
My thanks as well to everyone. I wanted to throw in one other quick announcement. Perhaps you read this in email, but we have a Twitter feed that we're monitoring. So that's hashtag NDS Kickoff. And so if you see anything that's interesting, this would be a great way to let the folks at home know what's going on at the meeting, as well as your colleagues, or if something occurs to you that's related to what you see. So we'll be showing some various tweets along the way on the display, but follow it on your own device. So we'll start with Ed with our introduction.
Thanks. Great, thanks. So we'll go ahead and dive in then. On the Twitter feed, by the way, Gabrielle's pointed out that the CIA has just gotten into the tweeting business, and so we're just on the heels of the CIA. So their first tweet was apparently, we can neither confirm nor deny that this is our first tweet, so at least I have a sense of humor. So let me just get started here. I feel like this is in some way the culmination of a lot of activities that have been going on in my own career. Most of my career was in relativity and astrophysics, so I was a practicing scientist. I'm doing less of that now, but a lot of the themes that are coming out here, in fact, I'll motivate this with my own, some activity in my own area, are all about data and sharing of data and so on. And then I spent 4 years at the National Science Foundation, particularly overseeing the Math and Physical Sciences Directorate there. And I was among a group of people, including Tim Killeen from NCAR, and Tim and I and a number of others, Myron Gutman in particular, talked a lot about data and drove a lot of the data policy that's in place now. So this requires, the things we're talking about require science, require a lot of policy, and Jane Silverthorne will be here in a few minutes to say the current thinking of NSF data policy. But so, for example, the fact that you now cannot submit a proposal at NSF without a data management plan is part of our doing from the last regime at the NSF, and that was really meant to put everybody on notice that data is really critical for the future of science and engineering. And so anyway, with the science and the policy things kind of in my background, now I find myself at the head of NCSA, which has been for almost 3 decades, or about 3 decades now actually, developing and operating infrastructure for the country. And so I think you need all 3 of those together, the policy, the science, and the infrastructure. And I think together we have people representing all aspects of those activities in the room here. So that's really what this is all about. So for me, this is a call to action to actually begin to build out some of this infrastructure. So let me begin to motivate it very specifically with a demonstration in astronomy, not a demonstration, but just a sort of an illustration of pointing out how for centuries, in fact, in astronomy, but this is typical of a lot of areas of science, people were doing some sort of an observation, they would record data, and even Galileo was talking about the importance of reproducibility of science. But that was for about 5 centuries or so, and suddenly, in astronomy, everything is changing from people doing science individually to providing large-scale data services. So, for example, the Sloan Digital Sky Survey, some of you in the room here have been very involved in this, or now the modern generations of these sort of survey telescopes, the Dark Energy Survey or the Large Synoptic Survey Telescope, will be providing enormous volumes of data served up to communities. And so no one will go to these telescopes and look through them. They will actually just be providing data services. And in fact, NCSA is one of the institutions involved in those 2 projects on the right, actually providing those data services. Now, when those data services are made available, it's a complete culture change, as Thomas was saying, a culture change in the way science is being done. And in fact, it allows lots of new things to happen that weren't really possible before. So this picture is of a Canadian student who, at age 10, Kathy Gray is her name, discovered a supernova because images that were being taken by Canadian Observatory were being made available to everyone. And so, in fact, you have kids discovering telescopes. And when I was at MPS, I gave a sort of a director's review talk, and I really highlighted this as sort of a sort of the changing face of science, not just the culture, but actually, having the sort of public outreach and what happens when data can be made broadly available. In just reviewing this yesterday, it turns out her younger brother then later also discovered a supernova. So with the same sort of thing. So 2 supernova discoveries in the family by age 10 is a pretty good record. So this is sort of, to me, like the generic sort of use case going forward. It's not a special case. It's like the way we should be doing science. And so now people would ask questions. How can I publish data if I've got some? How could I discover it if somebody else has it? And how can I verify it in this new world? And so what this meeting is about is people coming together to figure out how specifically to pull together tools to actually make this happen. And I think we're really on the verge of being able to do this. And you'll see some demonstrations in a very short while of the things that we can do already. So I wanted to point out that a lot of times when you hear about data, it's about, big data. It's about big instruments like, big telescopes, big hadron colliders, accelerators, photon sources, etc. But really, most of it doesn't get as much attention, and this you all know, so I'm really preaching to the choir here. The long tail, or the so-called the other 99% of science, it's really about that. And so these things are important, and they're very highly organized and well-funded and get most of the attention. But this is part of what we're really aiming at. It is that, but it's largely this, where we provide structure so that anyone, sort of the small science groups, and particularly like in chemistry or materials, where you have groups that are developing things, but they need to share data, and the materials genome is a very good example of that. And in fact, when I was at NSF, I was part of the early group of agency leaders thinking about how we would pull together the materials genome. And I'll come back to this over and over again, because to me it's a great example where you treat data, experiment, theory, instrumentation all on the same footing and try to provide infrastructures that they all come together. And that's been going on for nearly 3 years now. And unfortunately, the piece of it that's still underdeveloped is the data piece. And so I think we have some capabilities in this room that would allow us to move that whole thing forward. So the fundamental observation here, though, is not just that people work together by sharing data, but they actually communicate by sharing data. So all of us, when we send an email, it's basically an exchange of data. When we talk on a cell phone now, it's an exchange of data. When we look at something from the Large Hadron Collider, it's about an exchange of data. So this is now the fundamental observation, I think, about how research communities are moving forward. It's really increasingly just through the exchange of data. And that opens up science at scales that were never possible before, because you don't have to know the person that created the data. You just have to be able to find the data. So you don't have to all get in the same room and talk about your project. So let me jump right to a scenario. So we have a couple of different scenarios to illustrate what we're talking about, and then we're going to dissect them and say which pieces of this scenario, which sound very futuristic, are actually already in place now, and who owns them, who could bring them to the table, and what pieces are missing. So where should we focus our efforts on developing new stuff? So this is my view of the world now, which is an optical network connecting different instruments. So it's got, these are things that when I was at NSF, I spent a lot of time on these things. And just to show it's not all the new stuff, this is the Yale Library that has a Gutenberg Bible in it. So I want to sort of show that there's a span of time here as well, and everybody's getting into the same picture. So the library community, and we had long discussions with people from the Associated Research Libraries just even a couple days ago, and Rick Luce is here representing them, are very important. So this is what an astronomer or a group of astronomers and physicists now sees as their world, all these big instruments around the world. So here's the scenario. So this is a little bit into the future, but I think this group and people we're going to be working with can actually build out the services that make this scenario possible. In fact, even within the next couple of years, we could be demonstrating this. So in about, say, 6 or 7 years, this instrument called LIGO detects gravitational waves, and there's a transient burst event in the universe. So maybe it's a gamma ray burst or something, and some kind of an alert is issued, right? So then suddenly people get together and they're saying, wow, that's exciting. LIGO has seen something. So let's see, using some discovery services around data, what other data might be relevant to that observation. And so there's a thing called the IceCube Neutrino Observatory at the South Pole. And actually I had the privilege of visiting that when I was at the NSF. And so that is actually now already detecting cosmic streams of neutrinos, but it turns out with that, you can determine the direction. So LIGO may not know where, it just says somewhere in the universe there was a gravitational wave. But IceCube could say it came from that direction, because you can look specifically at the neutrino trails, the Cherenkov radiation in the detector. So it came from there. So they say there's something there from that data service. So then they say, well, let's look at optical telescopes and see if they saw anything. And so you have these telescopes surveying the universe every night. And so then they find out from gravitational waves, from neutrinos, and from electromagnetic observations that they can now begin to observe the same event. Now, these are not typically things that these people all work on. These are very distinctly separate communities, but by providing discovery services, it's possible to actually integrate them for a single observation. So then people want to do literature searches, so they go to their library, which is not necessarily your old school Sterling library at Yale. It now provides lots of open searches, and so we have a number of publishers, in fact, publishers represented here, and I think that's a very exciting part of this, that would support linking of data to their publications, and that's another very important part of what we're talking about here, connecting data with the publications themselves. So they find, by looking at similar events that might have been described in literature, the actual data that were described in describing those events. So then, what people do in this scenario is they use some data transfer services to find supercomputer simulations, and this is a simulation by a group in Germany from a few years ago of a gamma ray burst. And so this is carried out now, but in 5 years, it'll be much more sophisticated. And it turns out that people are now asking us at NCSA, will you provide data services around simulation output? Because we'd like to see someone's simulation. So Matt Turk is here doing simulations, cosmology simulations. They would like to provide their data for the world to observe because they're simulating the universe. And so in this case, there could be parts of the data that were never actually analyzed in depth by the people who did the simulations. And so in this scenario, people discover unpublished results of neutrino emission predictions that lead them to understand there's a new kind of a stellar object here. So then people get together, they say, well, we need to pull together some data from LIGO, from these ice cube detectors, from LSST, and some of the simulation data, and create a data object so that it collects it all into one collection so that other people in physics and astronomy can analyze this. So right now, it turns out there are some tools that could be adopted for this to create the data collections that you'd like to advertise to people. And so you create a new collection. You first make it available to your collaboration for analysis. So you can advertise merely for that collection of people too. But then ultimately, you submit it to an open access journal. So there's an open access journal called Physical Review X now, that's available now. There'll be more going forward, where they say that this data will be also reviewed with our publication after the publication is prepared. And then once it's published, of course, Physical Review would like to make that data set actually linked to that publication, and somebody's got to curate it. It's got to be available for the fullness of time. So then readers have access, again, going back to the cycle, to that initial data set, as well as to the analysis and so on. But then that's also available to others. So people developing, say, online astronomy textbooks or iPad versions could actually learn something new and immediately incorporate that, and then it scales out to thousands and thousands of kids who are watching what's going on in their 1 degree of the sky kindergarten, first grade classroom, actually watching a degree in the sky to see if a supernova went off last night. Could be very exciting. So this is the kind of scenario we're talking about. And there'll be another one. We have a little movie that we've made in lieu of an actual working demo a little bit later. But that's the kind of thing we're talking about actually trying to build. So in order to do this, I think we all know that's the kind of scenario we all have in our minds, or something like that, or a different version in a different field. But all science is being driven by this, but it's becoming unreproducible because, in fact, we don't make the data available. We don't know how to curate it well. We don't actually link things very well. We can't discover it, and so on. Growing call for open shareable data. So we'll hear from Jane Silverthorne in a few minutes about NSF. Phil Bourne, I think Phil is here. I didn't see Phil, but oh, hi, Phil. From NIH, we'll be talking about this. Mike Stebbins from the White House, OSTP, was going to be here. He had to cancel, but he just sent me an email and said, here's what you can say from the White House. So he says, we need to take steps to make scientific research data more liquid. The more we move towards open as a default for scientific research data, the more we'll get out of the research enterprises. And this is the last, most important sentence. It's time to take deliberate steps to make that a reality. So for me, that's what this meeting is all about. So, of course, we know that scientific results are shared through the literature, but there's no uniform mechanism to publish the data. So we want to talk about that here. How can we make that happen? And a lot of communities are actually very advanced in specific areas, and typically organized around large projects. And we have some representation from some of these projects that we've talked to. In fact, in our emerging consortium, all of these groups are actually involved. So, and even when that's the case, it's not for all data and it's not for all disciplines. this is the long tail problem. Of course, there are many, many aspects to long tail data. They could be surveys, it could be experiments and so on, various projects. But most of this is not available. And so we want to provide the ability for any small group on any campus to create a data collection and then to make that available for others. Am I doing on time, right? Probably over time already. 13 minutes. Oh, I'm doing really well. Okay, so hopefully I can make up some time here. So we need the ability for particularly to create the data objects for any small group of science to be able to do that, to publish it, to link it to publications, traditional publications, and so on. So hence came this idea for the National Data Service. And in fact, although we initially started calling it the National Data Service, I'm thinking maybe National Data Services sort of works a little bit better because it's not just one big monolithic service. It's going to be a federation of services. And it's not one nation. It's many, we have people here from around the world, actually. And so that, to me, it means National Data Services, and so that more or less captures the thing. But it's really the call to arms, an urgent need for national infrastructures for data. And so we need an integrated set of national scale services for all of these kinds of activities. We want it to be open and federating and it to be an architecture. So Ian Foster will be giving a talk in a short while about the possibility of developing an architecture with some tools that are already in place. So we have this in mind. And it will allow all of these things that we're talking about that I probably don't have to emphasize too much. So let me get into then the sort of ecosystem we've already begun to pull together. So when we began to talk to people, I was kind of stunned by the fact that every group we talked to, whether it was publishers or people who were involved in individual projects or different university groups or people who are developing other kinds of data services already, so the Astrophysical Data Service, for example, supercomputing centers, everybody immediately said, that's great, let's work together to do that. So that meant, sort of really struck a chord. And the fact that we have so many people assembled with so little notice, with no funding for this, also indicates to me that we struck a chord. So we have begun already to pull together different groups. And in fact, we did have a small proposal into NSF, and so that's under review, so we won't comment further on that, but it's very small compared to the overall activity. But the point was of pulling this activity together. That's when this entire consortium idea really blossomed, because everybody wanted to work on this. So we wanted to create these different kinds of entities that work together and then figure out how to connect and unify their various kinds of capabilities through an actual implementation of an infrastructure. And because we have the supercomputing centers together, so Mike Norman is here from San Diego, and TAC has been involved in our discussions, and we're here at NCAR as well. And so there are very long-term structures where people know how to build out, support national services, and the fact that we're beginning to really talk about working together is important. The fact that we have Internet 2 here, so Steve Wolf is here. We'll be giving a little presentation a little bit later. So Internet 2 has 250 research campuses. Every campus is grappling with these issues. So the University of Illinois, we're building out a research data service, and Heidi is here somewhere. Back here, the director of the Research Data Service at the University of Illinois that's emerging. Thomas Hauser was talking about the University of Colorado service. So a lot of these things will have the same functionality, and in fact, we'll talk today about this ability to create a data collection and then to deposit it somewhere. That's a service that everybody on our campuses needs. So the idea is, with these structures in place, we could build out a national set of sort of collaborative structures, I think, rather quickly if we put our heads together. So then we want people to be able to find the data. So I'll just go quickly over these because I think you all know instinctively, because you're working in these fields, that these are the kinds of things we need to do to help researchers use the data. So there are tools in place. A lot of people are using Globus online services already to move data. Data transfer services are very important and very popular there. So to be able to adopt some of those and perhaps adapt them somewhat for these kinds of purposes, and Ian will be talking about these things later. So to move data or to move analysis tools to the data, those kinds of things are possible and fairly routine now. To help people share and publish the data. So very importantly would be to have some collections of repositories. So we have in mind that we will not create like the master repository. No, we will have federated systems. Every campus will have something. big projects will have something, and there will be storage and repositories available, sort of more generic ones at national centers like NCSA or San Diego and so on. And then when you are creating a data object, if you don't belong to a big community where you know where it should go, we'll have a kind of a recommendation service that says, based on some basic metadata, you could go to the ICPSR at University of Michigan, or maybe you should go to the repositories that are being created for the generic sort of science at say, the San Diego Supercomputing Center. And we would then allow people to have DOIs assigned, provide links to publishers, and so we're really very interested on developing out the publication linking services for data objects and the publications themselves, and then to have this recommendation service as well. So the consortium has come together in the sense that many people have come to this room, and so we'll try to formalize that over the next couple of days. It requires many types of groups to collaborate, so I've been going over this. And then we want to then take, not just put in a proposal, say, to NSF and NIH and foundations and so on for $100 million, but to have smaller efforts, but that are linked together, that are coordinated, so that different pieces come together. And in fact, NSF's DIBS program, which was formulated while I was at NSF, and Rob Pennington is here, was an important part in actually formulating that, had that in mind, that this building blocks, DIBS, data infrastructure building blocks, could be put together, but we're now talking about more coherently assembling them into a national structure, and so to see where that might go. And then a number of organizations are already beginning to work with us, so we need to know in the breakout sessions, what should we actually do, what should our consortium look like, and where should we try to go with it. So there have been a number of questions that have come up around the room here and in the community about what's the difference between the National Data Service Consortium and the Research Data Alliance. And we've had Mark Parsons is here from the Research Data Alliance. In fact, a number of us are actually part of the RDA. I was at the last two meetings myself, and in fact, at the last meeting in Dublin, that's where a lot of this activity really started to build up. We talked to people were very excited about actually building out these national infrastructure services. So there's no attempt to duplicate or compete with the RDA here. We're expecting that we are a very close partner, and I had a long talk with Fran Berman the day before yesterday, who leads RDA US, and I think we're on the same page about how we work together, so that's good. So our focus is more on creating an infrastructure framework to build out these interoperating services. Narrow focus on the functions and leveraging existing capabilities. So if somebody has something that they use for their community or could be adopted as a generic tool, we'll either want to use it or we'll say it's one of several choices that you could have if you were to build out your own set of services. So what's next? So my main point is let's see if we can figure out how to actually get to work at the end of this meeting. I think you'll find much of this is actually possible right now. So it's kind of amazing what's actually possible right now. But what's lacking is sort of a national structure to insert it in, so these integration structures, and a framework to integrate it. And I think you'll see that there's some ideas right now already about how we could do it. We need people who are both doers and visionaries, and I think this room is full of both. In fact, many of us feel that we have both those qualities. So I think that the doer part is a very important part of this, so let's figure that out. At this meeting, let's look at what NDS should actually do, how should it be built, to take a bit of an inventory of what kinds of services are there and what is missing. And then to build, I think we could decide, we could do some demonstrations of our various technologies that are assembled in a new way. For example, at the upcoming supercomputing conference in New Orleans in November, or at the data curation conference, which is, I forget exactly when it is, but it's sometime after supercomputing. And so to figure out how to do that, to build up the momentum, and then to talk about how we fund it. And so I would just say NCSA is fully committed to this. We have a lot of talented staff in the center, and they're excited about this, and so we're going to commit our own resources to begin to build out some of these things right away, and I hope others of you are prepared to do that as well, to form this consortium and plan out future meetings. So I think hopefully I'm not too much over my time. That's what I wanted to say. So any questions before we move on to the next talk? Comments? Bob?
If you could go to
Ed, is this on? Yeah. Could you say more about the repository function? pointing people to existing repositories may work, hopefully will work, but I imagine there are always going to be things, especially interdisciplinary data, that are going to fall in the cracks. And one of my frustrations ever since, NSF set up the data management plans was that there was no established infrastructure to put any data into except in certain limited circumstances. So I'm thinking that this repository function maybe should be more than just the last resort, but should actually be something which has higher profile. But
Yeah, so that's a good point. I think that the thing we're trying to say is we don't want to replace existing well-functioning repositories, so we're sort of downplaying that slightly, so it doesn't look like we're trying to take over, the world with this. But to the extent it's needed as a primary resource, then that's fine too. And so I would suspect what would happen would be, as we build out some sort of additional capacity, probably focused around the national centers, that itself would then begin to become differentiated or connected to other federated activities. But so you're right. And I think that what you said does call out the urgency here, because that data policy has been in place since, I don't know, January 16th, 2011. I think I even remember the date when it was rolled out at NSF, or maybe it was 2010, but it's a few years later, 11, yeah. So yes.
Ed, you understandably spoke from the perspective of science, and certainly a big enough problem. You mentioned social science, ICPSR once. My question is, how broad are you thinking and defining data? Are you all the way to the humanities? Where is the line?
Yeah, oh, absolutely. It's all the way. It's all the data that people might have and might want to share and publish. And so Haystack is here from the humanities. Kevin is here. I don't know. Yeah, there. Yeah, and Kathy Davidson, right? So and there'll be some talks there, and then we're working closely. For example, talked a lot with George Alter from ICPSR. Myron Gutman from the SBE, Myron from formerly, or still I guess, the University of Michigan, is on the sort of advisory group for us as well. So we're thinking very broadly about this.
Margaret Hedstrom, University of Michigan. I'm the PI of SEED. Are you also thinking about the long-term sustainability? You mentioned that somebody has to curate it and take care of it for the long term. One of the obstacles, we're trying to do many of the things that you've just described in the SEED project, which is just looking at a small piece of the long tail around sustainability science. We have tools to match researchers with repositories. One of the real limitations is that researchers then want to know, my data will be taken care of forever. We can't make that commitment because no entity has made a commitment to providing the funding beyond the end of our award, and that is a major, major obstacle.
I know. When you say that, I feel like I'm still at NSF, because I had people saying this, and my response would be, and this was not an agency response, but maybe Jane will have a comment on this in a minute. But my response then was, I think it's the responsibility of agencies to think about the dissemination and the curation of the results of their research, including the publication, as part of the cost of doing the research itself. And so that's a very important part of it. And I think the more that the community speaks up, so I can say that sort of more freely now because I'm not representing NSF, but I think that's got to happen. That will happen. But it's also going to be, we're all in it together. Not that they should take it on totally, but campuses will have to do some as well.
Absolutely. But who does what is a really important question. I will just finally add that I'm chairing a National Academies committee that Carol Palmer is on. I think she's the only other committee member here, on digital curation, workforce, and education issues. And what is done by whom is a fundamental problem. So do curators do it? Do the scientists do it? And the question is, yes, it's great to have a way of matching up data that's ready to publish with a place to publish it and a place to put it. But how do you get it from the scientists' hands, the working groups, the multiple versions of the data, some of which is published, some of which is not, but some of the stuff that isn't published is still valuable. I don't want to make it sound like overly complicated, but if we don't look at those problems, we're not going to be able to fill this pipeline with the kind of data we want.
I know, so we'll get into these kind of discussions in the breakout sessions. I mean, I agree totally. But on the other side of it, I feel like we've been talking about this for a very long time, and let's just start building stuff, and it'll start to evolve. And if we do it in a thoughtful way, it'll evolve in the direction the community really wants it to go. So, okay, I should probably move on. Thanks.
So definitely bring that thought to the repositories breakout this afternoon. That would be great.